The first problem to solve recursively is to determine whether or not a string is actually a palindrome. Let's define what a palindrome is. A palindrome is simply a string word that reads the same forwards and backwards. So if you try to read from left to right and from right to left, they simply read to be the same string. So what we want you to do is to eventually write down a method which will take a string as parameter and then return either true or false, like a Boolean value, whether or not the input string is actually a palindrome. Let's look at some examples. What about empty string? Well, if you read from left to right and right to left, it's simply just an empty string. So of course it is a palindrome, right? Oh, by the way, so the method that you want to define is called isPalindrome, which will be returning either true or false, a Boolean value. And what about A over here? It's a string of a single character. Well, if you read from left to right or if you read from right to left, it's going to be just A. Of course, it's a palindrome. What about madam? If you read from left to right, M-A-D-A-M. If you read from right to left, M-A-D-A-M. So it will be just madam, the same word. So it is a palindrome. Let's see one more example here. What about race car? Well, if you read from left to right, R-A-C-E-C-A-R. Right to left, R-A-C-E-C-A-R. So it's also a palindrome. Read the same, forwards and backwards. What about man? Well, it's not a palindrome, right? M-A-N, if you read from left to right, N-A-M, if you read from right to left. It's a different string when you read from forwards or backwards. So it should be false. Right, so that's enough examples for you to really determine what might be the base cases and what might be the recursive cases. So I would say typically, if you want to solve problems on the string recursively, you have to think about definitely empty string or string of very small size, like of size 1 or size 2. And then you want to think about given the string of some arbitrarily long, like an arbitrarily long string. In that case, how you can break it down, the string into different parts to really assume the solutions and then combine them together. So that'll be the problem pattern, the solution pattern that we spoke about in the very beginning of this current module. Let me give you a little bit more visual hints over here. Okay, eventually we want to solve 3 problems on recursion on strings, but let's now talk about the first one. So the first one is just palindrome. Okay, the first one, palindrome over here. And for now, just ignore these two, right? We'll eventually get there. So for palindrome, so we know that race car is actually a palindrome. And this one here is not really a valid English word, but I just made it just for illustration. Okay, you can check it. This is not a palindrome, right? Because you can see A and S is already different. And this part here is also, this word here is also not a palindrome. So let me give you some hints over here, right? If I tell you that if a word is a palindrome, so that means beginning and also the end. Because if you actually want to read from left to right, the first character you will encounter is R, right? If you want to read from right to left, the first character you will encounter is also R. So the first and last character must match. Otherwise, it cannot be a palindrome, right? A counter example would be, you can see A and S over here. If you already see the first and last characters already different, you should not really bother to really look at the rest of the word. Okay, let's say in this case, if I look at, I know that the first and last character are already the same. So if I look at the middle over here, in that case, this is actually a palindrome. So that's already hints to you, right? Meaning that not only that the first and last characters must be the same, but also the middle part should be a palindrome itself in order for the entire string to be palindrome. But what about this? You can see the first and the last characters are already different. In that case, you don't even need to bother to look at the middle part. Okay. Third hints. What if the first and last characters are the same already? Do I need to bother to look further? The answer is yes. You have to look into further, because if you look at that, let's see, R and R, they are the same. I agree. However, if you look at the middle part over here, A-C-E-A-C-A, is this a palindrome? It turns out this is not really a palindrome, because A-C-E-A-C-A, from left to right, A-C-A-E-C-A, they are not the same string. So this is not a palindrome, right? All right, so hopefully that's kind of the hints you will actually get. And then, so now the idea would be you want to define this method here recursively to determine whether or not the input string is actually a palindrome, right? So that in this case, it's going to return true in this case, and it's going to return false in this case, and this one here is also going to return false. All right, so you can now pause the video and think about your solution. All right, assuming that you thought about it. Okay, so let me follow up with my hints quickly. Okay, so the hints I gave to you, I really expect you to do the following derivation. In order for me to decide whether or not a string should be a palindrome, right? Let's say this is the input string you're given. Let's say this is your input string. Okay, so this is the input string. So what you really want to do is to check whether or not the first and last character is actually the same, first of all, right? That's the first check you want to do. So whether or not the first and last character, are they the same? If they are, then you should really bother to look at the middle part. If they are not, in that case, they cannot be the palindrome. For example, let's say this particular string, right? So what about the middle part? The middle part here, you can think about this is indeed a strictly smaller string, right? Since you already took out the beginning and also the last characters. So you can think about this part over here. Okay, let me just do a solid line here. You can think about this part over here is a strictly smaller problem to solve. Strictly smaller problem. Because it has taken out the beginning and also the end character from the original string. In that case, we can somehow recursively solve whether or not this strictly smaller substring is actually a palindrome, and then combine that answer together with whether or not the first and last characters are the same. So that's really the idea about solving this palindrome problem. All right, hopefully you are getting that conceptually. Let's now take a look at how the Java code will be written. Let's now take a look. Okay, so what I would do is I declare this Boolean accessor method, like returning some Boolean over here, and then it's palindrome, and then it simply take a string. I simply call it word. Okay. So what about the base case? Let's go over some base cases quickly. Okay, if you look through the slides, we got two base cases. If the string is simply just empty, in that case, you can return true immediately, right? There's no need to really make any further recursive call. If the string is simply of length 1, like in the case of A over here, in that case, you also return true immediately, because every time, doesn't matter what the character is, you read the same forward and backward for a single character string. So what about if the length of the string is larger than or equal to 2, right? You can see I'm trying to be very careful in defining what the base cases are and also what the recursive case should be. In that case, as I said before, you want to compare the first and the last characters, whether or not they match. If they do not match, you shouldn't bother to really look any further. Let's say if they match, in that case, you want to go for the rest, the middle of the string, to make sure if it is really a palindrome or not. In that case, this part over here is about making some recursive call to solve a strictly smaller problem. That's what the essence for the solution should be. All right. Let's now take a look at the solution, given that we understood how the solution should be sketched. So this part over here is really the base case, right? You can see we are handling the cases where it's either an empty string or only a single character string. So this is really the base cases. In which case, we'll just return true. So what about the recursive case? So this part over here is the recursive case. So this part here is the recursive case. Recursive case. Okay. Specifically, you can see we are getting the first character. We get the first character over here using the char@, method from the string class, which I already spoke about how to use them, and also the last character, right? Which in which case we're going to use the length of the string -1 to get a maximum index, and the middle part over here is by using the substring method, right? You can see we go from index 1. Okay, thinking this way, right? Let me help you a bit further. Okay, let's say if this is the input string word over here, let's say this is word. Okay, let's say this is input string. You can think about this part over here, index 0, and this part over here is word dot length -1, right? So we are going to get rid of both, and then we want to get this part over here. This is really the middle over here. This is really the middle. And this part here is by calculating to say word dot substring. Okay, substring. It should be starting from index 1 for sure. That will be the first one. And what should this be? Well, basically this you can think about is we're going to go up to but excluding this particular value over here, right? So that's why you can simply put 1 and also this value over here, which is not going to be included, right? Remember we talked about the second index of the substring method being exclusive. Okay, so that'll be the word dot length minus 1, right? This will be exclusive. Okay, just to remember that. Okay, so let me just highlight this, and this one over here will be exclusive, not being included. Okay, that's exactly what you will see over here. All right, so we got the first character, we got the last character, we got the middle, and then the way we decide whether a word is a palindrome or not, we're going to say the following: the first character and the last character must be the same. And remember the short circuit evaluation, right? If this is already false, we wouldn't really even bother to evaluate this. If this is already true, that we will bother to actually evaluate this, right? That's exactly what the short circuit evaluation is, which we spoke about earlier. You should review it if you got any doubts. And this is really like a recursive call over here. So it's palindrome and the middle. So this is a recursive call to solve. So this is a recursive call to solve a subproblem with strictly smaller size. Smaller size, right? It's really important to notice that it's with a strictly smaller. That's really the key word. Otherwise, you get infinite recursion, as we said before, as a common error. And the middle over here is really what's really really important. The middle over here is simply just this guy here, right? The middle. Okay? And to decide whether the middle is a palindrome or not. Let's take a look at some tracing. Let's see how we can trace. Let's see the race car example. Let's say we try to invoke race car. So we say is palindrome, let's say race car. For simplicity, I'm not going to include the double quotes over here, right? But I'll just put race car just for simplicity, right? So this will just be equal to, right? Okay, actually, you know what? So this will actually make a recursive call. First, it's going to be something like this. It's going to compare R and R, the first and the second character. R and R over here, right? So it's going to say R is the same as R. And we're going to make a recursive call. In that case, it's going to be is palindrome and the middle part over here, which is going to be ACECA. Is that a palindrome or not, right? And for this part over here, we're going to, again, look at the first and second character of that, which will be A and A. So this will boil down into A equals A. And what about the next one? The next one will be, let me use maybe purple over here, CEA. So is palindrome CEC over here, right? And how about this particular recursive call? Well, we're going to do something very similar, right? So we're going to look at the first and last character, which will be C and C. And let's see this. And this one here will be, it can boil down into C equals C. And the last one here, it will be just E, right? E will be the middle part. And it's palindrome and then E. You can now see that we actually go into the base case. So this is the base case. So far, we haven't really got into the point where, so these are simply not equal to. I mean, the first and last character are not actually equal to each other. We haven't encountered this case just yet. So that's why we can even reach this point. So when we can reach the very middle of the palindrome, in this case, the base case will be just a single character, right? So you can see if the single character, that means the word length will just be 1 as the argument, right? You can see the word, in this case, will just be the E. In that case, it's going to return just true. Just return true. And then it's going to return back to over here. So that means this part here is going to be replaced by true. C equals C will be true. True and true is going to give you true. That means this part over here is going to be true, right? A equals A is actually true. True and true is going to give you true. So this part here is going to be replaced by true. R equals R is going to be true. So true and true is going to give you true. And then this will be true. So that will be the complete tracing for is palindrome. All right. So I'll leave that as an exercise for you, for example, to really see. Try to trace this one here, for example, to make sure you can get a like a false result over here. This one should be rather easy because as soon as you compare the first and last character, you already see the that they are not equal to. So you don't because of the short circuit effects, you don't need to even go you don't need to go even further to actually evaluate the middle string for the recursive call. And what about this guy over here? This one here, since the first and last character are the same, so you still have to decide over here, for which you got to compare A and the middle string. A and A are actually equal to each other, so you're going to make a recursive call to CEA, in which case you're going to compare C and A, which are different. In that case, you will return because of short circuit evaluation. Alright, so that will be the discussion for is palindrome. I hope that makes sense, but the most valuable lesson to learn from this example here is, given a string like this of arbitrarily long length, in that case, the way to really create a strictly smaller problem is by truncating the first and also last character to make a strictly smaller string. We'll see other ways to really make the problem smaller. We'll see. Alright, that's about it. If you go back to the slides, so now that's exactly the code I just went over with you. Let's now move on to the second problem.